Okay, so here we go. All right. So we're going to be talking about teacher noticing. You all have just spent like a packed 2 days learning all about gestures and body cognition and all this other stuff. But I know one of the things that has come up in our working group, and I'm sure in others as well, which is like, how do we handle this for many of us brand new modality that can be overwhelming? And so we are going to be talking about teacher noticing, particularly when it comes to students' gestures or learners' gestures. And my co-presenter, Margaret Walton, is here as the teacher noticing expert because that's not my area of expertise. So Margaret, you want to introduce yourself?
Yeah, I would love to. Hi, everyone. I'm Margaret Walton. I'm a doctoral student at the University of Maryland. And yeah, I have Janet Walco's my advisor, but I've done some great work with Caro and Virginia Flood about noticing and gesture. So we're really excited to share it with you here today. So I'm going to, I can't control the slides. Thanks, Caro. Jump right in. Martha, I missed the beginning of your presentation, so I don't know if you talked about an actual definition of noticing, so I apologize to everyone if this is redundant. What actually is teacher noticing? So the way that we think about it is it's the cognitive process by which teachers pay attention to and reason about student thinking. So with all of the interactions and all of the complexity and all the things going on in a classroom at one time, how does a teacher know what to think, know what to pay attention to, and then sort of think about that? And there are a few different definitions. The one that we're using is from Jacobs et al. And they divide it into basically 3 different parts. So the first one is you, as a teacher, first sort of have to identify what you think is an important moment. So kind of that filtering process of everything that's going on in a classroom. How do I identify, or what do I identify as an important moment? And for us, we're thinking about it in terms of an important moment of students' mathematical thinking. And then once a teacher actually identifies something that they see as important, well, how do I as a teacher reason about that moment in terms of students' mathematical understanding? And what's really important here is not thinking about students' ideas in terms of, oh, that was right or that was wrong or that was correct or incorrect in terms of an answer or or the answer that we're kind of quote unquote looking for, but based on how the student is expressing their ideas, how am I understanding that expression, and what is it saying about the student's mathematical understanding? And then finally, once a teacher has reasoned about that moment, deciding how to respond to it. And of course, this is all happening very, very quickly because it's all in the moment in a classroom. And you can switch oh wait, no, not yet. I have something else to say about that. Currently in the literature, teacher noticing has primarily been looked at in terms of how students are expressing things in verbal or written form. So lots and lots of folks have done that, including Miriam Sharon and Beth Van Ness and lots of other people. And what we're looking to do is actually add to that work to include other modalities like gesture, sort of as another means of understanding student math ideas in the moment. So now you can change the slide. And we're going to show you an example here. You're going to get to experience Caro's and my acting skills. So get ready for our theatrical debut. But we're going to do a reenactment of a video that we think really kind of shows this idea of beyond what you can get beyond students' verbal and written expressions. So I'm going to sort of set up the context of what happened in this video. And then Caro and I are going to play the role of 2 students. So it was in a 10th grade geometry class. They were having a whole class discussion. And they were discussing with their teacher what happens to the area of a square as you increase the perimeter by a factor of n. So students were first working with numerical examples. So the teacher asked, what happens if you multiply the perimeter by a factor of 3? What happens to the area? And students figured out, oh, it increases by 9. What happens with 4? It increases by 16, 5, 25, so on and so forth. So once the students have figured out the pattern, the teacher then asks the students, well, why is this happening? So why are we getting this increase by a factor of n squared? And a few students offer explanations, 2 of which Caro and I are going to reenact right now. So Caro's going to go first, and then the student I play is building on Caro's student. I think you're muted too, Caro.
Okay, but my gesture, okay, I got space. Now to go to our transcript thingy. All right, so I am a student. All right. All right, so for both of the shapes, you find the area by using 2 dimensions. For the triangle, it's the base and the height. And for the rectangle, it's the length and the width. So if you multiply those 2 dimensions by a certain number, you're gonna have to square the total area because you're using both of those dimensions. So it's not just like you're multiplying something. It's not like you're multiplying the shape by 5 times. You're multiplying it by 5 times 5. So that's why it's 25 by 25 times.
So I think I get what they're trying to say. Like when you're increasing, you're multiplying both sides by a certain number. And so if you have a square, it's essentially this number times this number. You see what I'm getting at? Like you've got a square and you're multiplying by 2, okay? And then you've also got to multiply by 2 over here. So it's like 2 on both sides, which is squaring. You get it?
Thank you. We were magnificent. All right.
You can hold your applause. We are.
All righty.
But I think one thing we could do here, Carol, before we get to the next part is maybe see if anyone has some ideas of kind of what the 2 of us were trying to express there, and how it was maybe different. And we can do gestures again too, if you need us to.
Can I start?
Yeah.
So it looked like what Caro was doing was very much about like the area. She had the areas in chunks as she was describing, whereas you had lengths. You started doing like actual addition using more than one tool to show that the length had doubled. So you're looking at length and width, whereas Caro is looking at just area. And I'm doing it myself. I'm like mimicking what they were doing, doing that thing we were talking about. But that's what it seemed like the difference was. And it wasn't as clear with just the area until I saw it again with Margaret using the length and the width, if that makes sense.
Yeah, Tamisha, that's really interesting. So we've had similar conversations about this. And I actually, it's so interesting that you say that, because I think when I think about it, and I've seen this video, the actual video, like more times than I'd like to count. I think about it in terms of, yeah, this is almost like doing the area, but I wonder, it's so funny that we interpret it in different ways, because I think either works. Any other ideas?
Well, I was just building off what Tamisha shared. I think when you added the remote control or whatever that is that you've got there to make the double length and the double width, then that really helped to kind of add some the physical model to what's actually happening to each part of the rectangle,
Agreed. Yeah. And it was, almost that addition of the gesture, maybe building on the other students' ideas that, that made it more concrete in that moment. Any other ideas, or we can keep going here?
So I'm just keeping an eye on the time, and I'm going to actually suggest that I think those were some great ideas. So I think we can just skip the part where we tell you what we think the students are doing. Margaret, I'll pop that image up really briefly because I think we have an important point to make about it, but let's not describe the graphics because that way I want to make sure that we have time to do breakout room activities because we've come up with a really fun one for y'all. All right. So I'm going to share. All right.
Yeah, so what was so interesting in the video is we saw these gestures and you all commented on kind of what you thought about these gestures. But what was actually taken up in the class was when a student came up and actually drew an idea on the board. So the really interesting thing was, even though students were showing all of these like interesting ways and sometimes the same way to talk about this, students and the teacher have been kind of conditioned to take up, just either verbal or written responses as sort of assessing understanding. So our idea is, well, if you can add in the gesture, what would that have done to sort of build the kids' understanding who did the gestures, and then also what would it do for the class understanding as well? So I will throw it over to you, Caro.
Awesome. That was perfect. Okay. You can come this way. It's fine. All right. So we're going to go into breakout rooms. We're going to have 5 minutes where you need to turn your camera and your audio off and have your little bubble. And then you're going to secretly develop 2 different gestures around the same sort of content / moment of learning. You can have the same spoken language to go with your gesture or something different. It's totally up to you. But you just come up with 2 interesting gestures around this moment of mathematical learning. And then after 5 minutes, we're going to have you turn your cameras back on and share your 2 gestures paired with spoken language one by one, but you don't tell your group what you mean by those gestures, not even what content or what moment of learning you're aiming for or anything. So you're going to share spoken language in a gesture, and then the group is going to try to interpret the meaning of the gesture and the spoken language and decide, and interpret it and decide how the teacher should respond. And then the sharer will say, well, this is what I originally meant when I was developing this gesture, etc. Now, I'm going to put a link in chat that'll take you directly to this slide so you can come back to look at it. We'll give you warnings at 5 minutes to switch to sharing, and then we'll probably give you another warning at 12 minutes to say you have 3 minutes left. Now, we're not sure how long it's going to take for people to create these and share them and etc. So if you finish and you get bored, then just come on back to this main space. If it's just Margaret and I, then you can just share with us. And if lots of people start coming back in 2 minutes, then we'll know, wow, that was really fast and easy. Okay. This should be the link directly to that slide. I'm going to open random breakout rooms with 4 or 5 people each. Margaret, it's going to try to put you in a breakout room. Tell it not to. All right.
Hey, Carol, there was a clarification question about that this can be about any mathematical topic.
Yes, anything you want. Yep. All righty, go have fun, folks.
Okay, 5 minutes and
remember
counting.
To turn off your camera. I'm going to broadcast that. Awesome. All right. Anybody here that wants to be in a room and just can't get there somehow?
I'm okay being here. Let's see, Aaron, Uhon, and Danny. Wonder if they want to go somewhere.
All right, Liza, I'm gonna send you someplace. Let's see. I wonder why.
Sorry, I'm trying to potty train a toddler and feeling
Oh,
miserable.
yeah.
So
Oh,
I
yeah.
apologize for the background.
Mm-mm.
Okay, let's see,
All right.
we have Juliana. Oh, Uhun, you're in room 1. And Juliana. Oh, I saw her.
I think they must be away for a second.
Okay.
Yeah. But yeah. Tenzia, what do you think about our activity? Isn't it silly?
I love it. And actually, I've been doing all these embodied cognition workshops for the math circles group throughout the country. And I do a ton of these pair up, and I give them the theorems, and they're supposed to, in their groups, do exactly this. And then they come back and share with the other group. It's amazing all the different things that they come up with. So yeah, I love it. I don't think it's crazy. I mean, unless I'm crazy too, because I do it all the time. Yeah.
Excellent.
And that was the idea that I was sharing yesterday with our working group, that they could do something like that as even part of a review.
That's right. I did not even make that connection. And I totally should have just been like, you all just better make sure to come to our session. Yeah.
That's so funny. Yeah, it's really fun. Even if it, just one thing I think it does is just sort of spur teachers to start paying attention to gesture, right? You've done this activity, and then it's like, I mean, it's almost like Carol, like the paper, just like a little nudge to, and this could be the activity that nudges.
And then if the teachers implement it in their class, it's a way for them to help students pay attention to gesture.
Totally.
Yeah.
Totally.
Yeah, we should Margaret, if we remember, we should try to mention at the beginning of this or at the end of this, or Tenzia, you can bring it up, because you're right, this perfectly connects to what you were talking about. Yeah, and I just didn't make the connection yesterday. Yeah.
And it connects to what Molly's going to be talking about in assessment. And who else talked about assessment today? I'm like, everything's blurred, but but that it's a great formative assessment.
Yeah.
Totally. We talked about that in our group too.
Mm-hmm.
That just, I think Jen was just sort of like, I just watch my kids. That's my formative assessment.
And I think it gives students who bring in different talents an opportunity to shine. Like if you're going to create a skit or something,
right?
Like, oh my God, this is what I'm good at. Our theater majors, our art majors, so our dance majors.
Yeah, like I just keep thinking about that with Brooke's work, and just like how amazing is it both for fine art majors to wow math people, and for math people to be wowed by the art people. Just like, when we're all given good access to mathematics in a way that leverages our strengths, then we're amazing. Everybody's amazing at it.
Yeah, it kind of reminds me of a time I did professional development. And this was in Western Nebraska. So there weren't a lot of teachers. I mean, I think there were like 20, but they were from kindergarten to 12th grade, all in the same room. And so I had to create tasks where they could all engage in them in different ways. And it was amazing that the high school teachers would say, wow, that solution is beautiful and elegant compared to all my symbolism over here that I have. And the elementary teachers are like, wow, we didn't know that you could use math in that way to now represent what it is that we have over here with this other representation.
Right. That being a secondary being a former secondary teacher, that always, listening to elementary school teachers talk about the same concept or similar concepts, I'm always like, wow, that is so interesting. And yeah, I always really enjoy doing that.
Yeah. Yeah, because I think secondary teachers go to professional development to do math. And I see that with collegiate teachers too, when I do professional development for them. It's like, yeah, give me a cool math problem to work on. And so it was really, really interesting to just see the different ways in which they would approach it. And again, the different ways in which they could shine, which I think is the nice thing about activities like this.
Totally.
So, given the schedule,
Oh yeah, what do you want to do?
so I mean, I think that like, I mean, I think we'd be fine just like when people come back, just asking just for an example or two from the groups. Let's be like, did you have a really cool one, or did someone in your group do a really cool one? Like, let's share quickly. And then, you know, people can always contact Margaret and I, or etc. You know, like, but really the goal of this was to get people sort of hopefully gaining a little more confidence in their ability to interpret, to notice. And I think that's what's happening right now. So we do not have to delay Molly's keynote. Is that okay, Margaret? Sorry, that means it's shorter, but
you're welcome to take extra time, because Molly and I have been messaging also, and she's like, she just asked for a little break in between, which I said for sure.
Yeah, well, I think it's also like I think no matter what, we're gonna go a little bit over, but then I want to wrap it up to make sure that everybody else can actually get a 5-minute break at least.
Yeah,
go walk around and so on.
All right, sounds good.
Yeah.
I'll let you be in charge. So
okay, this once and then never again. Yeah, until EMIC 3.
Exactly. How much more time do they have? Do the participants or?
So I gave them the 5-minute warning, I think about 5 minutes ago. Or I gave them the time to start sharing your gestures with people. So my alarm will go off probably in another 5 minutes.
Perfect.
And we'll see. Yeah. Yeah, Tenzia, this has gone like incredibly smoothly. So you've just been knocking it out of the park. It's amazing.
Well, I mean, I just had to put the thing together, which was a nightmare.
Right.
It was only a nightmare because everything kept changing.
Yeah.
Not knowing what to expect.
Yeah.
But yeah, I've gotten lots of feedback from folks. So
yeah, it's been great.
And Francisco actually emailed me also, and he's like, what a great team. Oh, and I forwarded you all his material.
Oh yeah, so I went to those links, I couldn't access them, so I requested access and put a notice to who I was.
Oh, good.
So yeah, and when people send me their materials, I'm putting them in our shared drive. I'm not putting them on the website unless I get explicit permission for that.
Yeah,
so
I think that's exactly the way we should do it. Especially people who have video data.
Yes. Yeah.
Yeah, you know what I love, and I know we created this schedule back in almost 2 years ago, but but I love how everything just is like, oh, and this feeds into this next part, and people can kind of tie in the previous talks. It's been great.
Yeah, I feel like you put the keynote speakers and then you like organized the keynote speakers perfectly, and then like slotted us in as speakers perfectly. Like, yeah.
Yeah, I'm really happy with the order of everything. And I think Molly's just going to do a great job wrapping it up with the thing. Was it Angela who asked about?
Mm-hmm.
Yeah. With the cultural aspect, taking that into consideration.
Excellent.
When I do Math Fest and organize that, like the whole MAA committee then takes, or the MAA staff take the whole next week off. It's like paid time off because during Math Fest, they're working double. I'm just like, can't we take part of this next week off because we
Yes.
worked all weekend?
Yes, please. Yeah. I was thinking about that, and like if we are able to do like a small virtual EMIC too,
Mhm.
it's like, excuse me, like we should totally like do it during the week or have it be Friday, Saturday or something. Because I think I need my week. I think everybody probably needs their weekends even more than usual.
That's true.
Yeah. Yeah, but you know, I mean, I guess that but then we'll have more people ducking in and out.
Because
but
they
I
have to teach, yeah.
Right, but this is also one of those things where it's like, you know, it's okay to also normalize I'm attending a conference. Yeah, it's virtual, but that's irrelevant. I cannot attend any of my committee meetings or whatever.
Right.
So
Yeah.
yeah, we'll see.
That's a great point.
Let's
Yeah,
see. Do you want to bring them back?
That's
the time?
probably a good idea. I'll bet they're having too much fun.
I bet they are laughing.
I
That's
bet
how
they
much-
are.
Oh my gosh, when I do these things, people just die hysterically.
I mean, it's like math charades, right?
That's exactly what
Yeah.
Molly said.
Yeah.
Okay, I just messaged them saying I'm giving them 2 more minutes and then I'll hit the close room button. And my watch hasn't gone off and I don't know
Perfect.
if it's still working or whether it's, who knows. Anyway, but that'll hopefully that way, if anyone hasn't shared yet, they'll be able to share real fast.
Oh, somebody said that they were a little distracted by your awesome t-shirt, Carol.
It is awesome. It was a gift from like one of my best friends, so I'll have to let her know that it was fully.
Oh, it was
appreciated.
Tamisha. Tamisha said that.
Yeah, it is super cool.
Mhm.
Yep, it makes me wish I had a dragon and more cats. Yeah. Yeah, and Martha asked a really good question. I don't know if you noticed that, Margaret. Martha said, I want to think about whether the second student's gestures built on or mimicked and then elaborated the first student's gestures. And
that's how I interpret it. Yeah.
Yeah.
Totally.
It's like, I feel like I had to watch the video multiple times to be able to ask that question. Martha's like, I've seen these mimic, you know, I've seen you reproduce these just once, but here's my idea.
Right.
It's like, you're so good at this ridiculousness. Jeez.
And I mean, if we think about, if somebody says something verbally and the second person pretty much understands what the first person said, they pretty much revoice what the first person said. And I think there's a whole lot, I've talked about this before, regesturing, which I also ask my students to do intentionally. Like, could you regesture what Sally just did? Or could you interpret Sally's gestures? No different than, can you interpret what Sally just said?
Totally.
Yeah, and I think that's something that I feel like, Margaret, you and Janet have been more deeply involved in this teacher noticing stuff. I'm hitting the close button now in all the rooms. So you all have been thinking about this a lot more, but this, like, I think you were just using the revoicing language because that's what's used in teacher noticing, but with gestures and emphasizing that modality. as a way you can revoice as well. But we didn't actually, well, I guess we wouldn't have had time anyway, but it would have been absolutely fascinating to add that as a piece as well.
Yeah.
in
Well, and I
this.
think that's what a lot of Virginia's work is on too, is the revoicing and seeing, you know, teachers or tutors kind of revoice whatever their students, the gestures their students have done.
Well, it looks like we're getting a reasonable number of people back before they're kicked out of the breakout room. So that means there was like enough time for you all to share your gestures-ish. Okay, good. Because we were worried and then we cut it short and then, yep. Alrighty, welcome back, everybody. In order to, okay, so first of all, did everybody have fun and get some laughs in when they figured out what everyone else was gesturing about? Sweet. Okay, good, good. I think we have just enough time to share maybe 2 hilarious or interesting or peculiar gestures. So if you or somebody in your group had a really amazing one, then please share it with us.
No need to raise your hand. Just go ahead and start talking. Or I will call on you. And
She
I
will. She
and
will.
I like people who haven't spoken to speak. I really am big on giving everybody space to share. And so, like, for example, Taylor, gosh, she's like, I know she's going to call on me. I got to leave. Did she just really leave? No, Taylor Darwin. Oh, she might be with the baby. Let me not call on her. Kevin Rains. I think I have. Kevin, how about, do you want to share what you guys learned? Why am I calling on people who don't have their cameras on? This is my teacher mode. Let me call on people who aren't paying attention. Let's see, Jennifer St. John.
So we talked about quite a few. We talked about one-to-one and on-to. We talked about commutative property. We talked about the commutative property, the associative property, distribution. We talked about angles, you know, acute and right and obtuse. And you guys, am I missing any of the other ones that we talked about?
Maybe the dynamic versus static angle thing, that you have like this, well, dynamic emergence of an angle and dynamic like representation of an angle, which is kind of like two sides of the same coin.
Yeah, but one's particularly temporal, right?
I think it was one kind of like looking at an angle like this, and one like the angle's just like that. Is it moving along the arc, or is it kind of static? Here's the angle.
Got it. Did anybody? Oh, go ahead.
Yeah, I just want to comment on Dennis. So you're saying that is static, but you're still rotating it around, so it's not static anymore.
No, I was just saying the angle wasn't changing. It was just never mind. I guess I was thinking about the movement as we go around the unit circle. You kind of have this feeling that you're like going counterclockwise as the angle is changing, or when you just say pi over 6. That those, yeah. So not so much the static nature of it. Thinking about the movement around the unit circle.
Yeah, but that's particularly interesting, right? Because if somebody is like this angle versus this angle, then you really get a sense of how they're contextualizing or developing this angle. Yeah.
Can also talk about, you know, as we were talking earlier, you know, this is angle 1 versus this is the measure of angle 1. You know, it really can go back to that idea as well if we think about it in that regard. One's that active motion of measuring, and the other, oh, sorry, of course my daughter's calling right now, let me decline her. But it really can talk about the that measurement. So, and part of me now, I'm going to go make sure she's okay.
that is perfect. I feel like tying it right back to Mitch's talk, that is excellent. Jennifer did that for us. So now we should just take a 5-minute break.